Okay. Okay. As far as the Zoom recordings are concerned, I've had a problem with the first couple of recordings. In all honesty, I lost the files because they clashed with my Math 130 class. Because this class starts on the heels of that one ending. And so what happened was I had to convert my Math 130 Zoom lecture into an MP4 file. And as that was occurring, I then opened up a recording for Math 082, but those two operations clashed with one another. And somehow I lost the Math 082 file. So I was not able to convert that into an MP4. However, I already did convert my Math 130 file into an MP4, so this recording should work, and I'm going to investigate that so that doesn't happen again. But I will be posting a link on Canvas for Zoom recordings, and okay, just a link to get into the Zoom meeting. Okay. Well, the link to get into the Zoom meeting, somebody chatted me, is right on the main page of the class. So you go to our class, ladies and gentlemen. And right on the main page, there's a link to getting into our Zoom. So, I mean, is that how you guys are hooking up with Zoom here? Is through the link through the Canvas course site? I'm assuming that's how we're hooking up, right? So on the main page of our course, there is a course Zoom link. All you do is click on it, and it should take you to the page to join the meeting that is going on. All right. So due tomorrow night, ladies and gentlemen, will be the what? Will be the quiz by midnight tomorrow night, correct? On chapter 1. Now the classwork, normally I like to have the classwork by midnight, the same day that we do it. So classwork by midnight and the quiz by midnight tomorrow night. Does that make sense? All right. So we good on that or not?
Yeah.
Yeah.
Do you want the homework turned in along
No,
with the
no.
quiz?
No, textbook homework is not due until the day of the exam. This is just.
Okay, so you just want it turned in along with the quiz?
All I want you to turn in is just a quiz. No textbook homework.
Oh, along with the final exam?
Textbook homework is due on the day of the exam. So when's our first exam? If you go to our schedule, when's the exam on chapter 1 and 2? Because that's when the chapter 1 and 2 textbook homework will be due. So if you go to our schedule here, you can see that the chapter 1 and 2 textbook homework will not be due until October 6th.
Oh, okay. Oh, October 9th.
Wait a minute here.
A 9.
October 9th. That should be 9th. What? I don't know why that's missing. It's October 9th. Yeah. October 9th, ladies and gentlemen, is when the chapter 1 and 2 textbook homework is due by midnight.
Oh, okay.
So don't turn any textbook homework into me until then. I will specifically indicate at that time through an email what I want you to turn in as proof of having done your chapter 1 and 2 homework. Okay.
Okay.
Okay. So
Thank
just
you
hold on.
for
Yeah,
clarifying that.
yeah, you're welcome. Just hold on to it. Keep it in the notebook and don't lose it.
Right.
And when the time comes, I'll have you turn in a certain number of pages that I want you to get to me as proof of having done it. Okay.
Okay.
So again, what's due by midnight tonight? Just the classwork. What's due by midnight tomorrow night? Just
The
the
quiz.
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 One. That's it. Okay, that is it. All right, we all clear on that now? Oh,
Yes.
all right.
Yeah.
All right, so here we go, ladies and gentlemen, section 1.5 is going to have us addressing multiplying and dividing positive and negative numbers. Okay. So in general, I like to call positive and negative numbers signed numbers, numbers that are positive or they could be negative, signed numbers. All right, let's just review real quickly our rules of signs that we learned to date here. A positive plus a positive is always a what?
Positive.
Positive.
And we add. Example, positive 2 added to a positive 3, positive 5. A negative added to a negative always gives us a what?
Negative.
Negative.
Negative, and we add. Example, negative 2 added to a negative 3 nets us a negative what? Negative 5, correct? All right, when we mix the signs and add a positive and a negative, or a negative added to a positive, in this case, the rule has 2 steps to it. First, we take what? Difference?
Find the difference.
Difference. Then add it up.
And then we attach what? Larger sign, correct? Larger sign? Attach larger
Right.
sign. So some examples would be like a negative 5 added to a positive 7. That would give us a positive what? 2. Or if you add a positive 3 plus a negative 12, that would net us a negative what? 9, correct? All right, then we got into subtraction. Do you remember how we subtract? Subtraction is like adding the what? Subtraction is like adding the opposite.
Opposite.
The opposite.
Like adding the opposite, right? That's how we learn subtraction. So if I got 5 subtract 20, that's really 5 plus a negative 20, which would net us a negative 15. If I have like a negative 6 subtract a negative 14, that is going to be negative 6 plus 14, which in this case would net us a what? Positive 8, correct? That's how we should think of subtraction, like adding the opposite. All right, so those are all the rules we know so far up to this point. We're now going to extend those and look at our last operators of multiplication and division. All right, so another rule here, ladies and gentlemen, is what happens when we multiply numbers together that have the same signs? A positive multiplied by a positive or a negative multiplied by a negative?
Keeps the same time.
In both cases, we get always a positive. So a positive times a positive or a negative times a negative is always a positive. Always a positive. Word of caution is we have to keep these 2 rules compartmentalized in our mind. Keep them separate. A negative times a negative is a positive, but a negative plus a negative is always a what?
A negative.
Negative. Careful on these, as these are often confused in our minds. So adding 2 negatives always gives us a positive, but adding 2 negatives always gives us a negative, but multiplying 2 negatives always gives us a positive. Try to keep those separate in your mind. Another rule, what happens when we mix the signs and multiply? A positive times a negative or a negative multiplied by a positive? In both cases, we're always going to get we'll always get a negative. So when you have a positive times a negative or a negative multiplied by a positive, you always get a negative. These are the rules for multiplication of signed numbers. All right. Those are the rules for multiplication of signed numbers. So let's try a couple of these out here. If I have, let's see, negative 12 multiplied by a negative 10, what's this going to give me? A negative times a negative is always a
Positive.
Positive.
It's be positive 120. If I have a negative 12 multiplied by a positive 3, what does this net me?
Multiply.
Negative times a positive.
Negative.
Negative
Negative.
times a positive is always a negative. So this will be a negative and it'll be a negative 36. True? Okay, so it's a matter of remembering these rules here. That's basically what it comes down to. And this is also true for, fractions and decimals too. All right. Now, what happens when we raise a negative to a power, specifically an even power? Like if I got this right here, what do you think this is going to evaluate to? Anybody want to take a guess there?
A positive.
Negative.
All right. Some are
A
saying
negative
positive,
sign,
some are saying negative.
would it be a negative sign? Or a positive nine?
Yeah, this is often an area of great confusion in mathematics, so we're gonna have to be very extra careful here. Ladies and gentlemen, it's not the negative sign that's being raised to the second power, only the 3 is. So we need to view this negative sign in this situation as the word opposite. So this is to be interpreted as the opposite of 3 squared, or the opposite of 3 times 3. And what's 3 times 3? 9. And what's the opposite of 9? So that should be negative 9. Negative 9. Now I want you to contrast that problem with this one here. It looks like these are saying the same thing, but they are not. They're night and day differences. So we got to be very careful here. This is saying the opposite of 3 squared. This is saying negative 3 squared. So this is saying negative 3 times negative 3. And a negative times a negative is always a what? It was a positive. So this would give us a positive 9. So please highlight these 2 things in your notes so that they jump out and remind you. I know it looks like they're saying the same thing, but they are not saying the same thing. This is saying the opposite of 3 squared. This is saying that we need to square negative 3. Okay. I know it seems like a subtlety, but and it is a subtlety, but it's an extremely different situation here. So we got to be very careful here. Okay. Now, when you raise a negative number to an odd power, you can get away with it. For instance, if I have this here, negative 2 to the 3rd power, this is saying the opposite of 2 to the 3rd power. So again, this negative sign is the word opposite. So it's the opposite of 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. What's the opposite of 8?
Negative 8.
Negative 8. Now, what if I put the negative 2 inside the parentheses and the exponent 3 outside? This now is to be interpreted as negative 2 to the 3rd power, which is saying negative 2 times negative 2 times negative 2. Okay. Now, if you work from left to right, a negative 2 times a negative 2 is a positive what, 4? This gives you a positive 4. And what's a positive 4 times a negative 2 now? Positive times a negative.
Negative.
We'll be back to a negative. So this is going to give you negative 8. So the moral of the story is this: when you're raising a negative to an odd power, ladies and gentlemen, like the 3rd power or the 5th power or the 7th power, in either case, whether you have parentheses or not, you're always going to get a negative. Negative 8 in both cases. But when you raise a negative to an even power, like the 2nd power or the 4th power or the 6th power, you got to be very careful. This is saying the opposite of 3 squared, which is negative 9. This is saying negative 3 squared, which turns out to be a positive 9. So,
That is so confusing.
so you got to be careful. When you're raising a negative number to an even power, be very careful, because parentheses can make all the difference in the world, okay? But when you're raising a negative to an odd power, you don't really have to be that careful. It's always going to be a negative, all right? Always a negative. All right, so I just wanted to caution you on those subtleties in math, because these are always areas where many people make mistakes. We just got to be careful, right? So I would just, highlight this. Take a highlighter out and highlight this. I would highlight this also, so it jumps off your pages and reminds you of those things. Probably why you always bring a highlighter to class. That would help out a lot. Any questions on this page, ladies and gentlemen? We've learned the rules of multiplication. Okay. And when you're multiplying same sign numbers together, you get a positive. Opposite sign numbers multiplied together always give you a negative. Always true. Now, what happens when we multiply a whole bunch of negative numbers together? Like if I got a -1 times a -3 times a -2 times a, let's say a -2 times a -1. Okay, what's this product going to be, positive or negative? Well, if you work from left to right, two numbers at a time, we can find out what that would be. Let's do it the long way first here, okay? So what's a -1 times a -3? Negative times a negative is always a
Positive.
Positive.
positive 3. Okay, now we're gonna multiply the next two numbers together. A +3 times a -2. What's a positive times a negative?
Negative.
Always a negative, so that'd be -6. Now we multiply left another two numbers together, left to right. -6 times a -2.
Positive 12.
Positive 12. Finally, a positive 12 times a -1. That's us what? Negative
Negative
12.
12.
All right. This was the long way of doing this problem here, ladies and gentlemen. There's a little shortcut, and I don't mind if you take here. How many negative factors do you count here in this entire expression? How many negatives do we count? 1, 2, 3, 4, 5, correct? So I have a question for you. Do we have an even number or an odd number of negative factors in this expression? Odd or even number? We got 5 of them. 5.
Odd.
Odd. So this is the way it works. When you multiply an odd number of negative factors together, ladies and gentlemen, you're always going to get a negative, always a negative. When you multiply an odd number of negative factors together, you always get a negative. And then 1 times 3 is 3, times 2 is 6, times 2 is 12, times 1 is 12, -12. So when you multiply an odd number of negative factors together, you always get a negative. What happens when you multiply an even number of negative factors together? What do you think you're going to get in this case? Well, if we work from left to right, what's a -1 times a -3? That'll be a +3. And then you're going to multiply a +3 times a -4. Positive times a negative gives us a negative again. And then finally, what's a negative times a negative?
Positive.
Back to a positive. So the moral of the story is this: when you multiply an even number of negative numbers together, notice there's an even number here, 1, 2, 3, 4 of them. When you multiply an even number of negative numbers together, you always get a positive. Always a positive. And then 1 times 3 is 3, times 4 is 12, times 2 is 24. So you could have done that using that shortcut there, okay? Product of an odd number of negative numbers, always a negative. The product of an even number of negative numbers, always a positive. All right, so what if I gave you this one here? 5 times a -2 times 3 times a -1 times a -2. Is this product going to be odd or even? Excuse me, going to be positive or negative?
Is it gonna be negative?
How many
Negative.
Yeah, how many negative factors you counting here?
3.
3.
2, 3 of them, which is an odd number of negative factors. So this will be a what? Negative product.
Positive.
Guaranteed. No, it's going to be a negative product. When you got an odd number of negative factors, it's always what? Always a negative. Okay. When you have an even number of negative factors, it's always a positive. Down here, we have an odd number of negative factors. 1, 2, 3 of them. So it's going to be negative. Now, what's 5 times 2? 10. What's 10 times 3? 30.
30.
30.
30 times 1 is 30. 30 times 2 is what? 60. It will be a what? -60. Will be a -60. If I made this one little change in this expression, made the 5 a negative, now what would be the product of these numbers? What's the product of these now? Positive or negative?
Positive.
Negative.
Well,
Oh.
how many negative factors you count? 1, 2, 3, 4 of them. Now there's an even number of negative factors in here, so our product better be not negative, but what?
Positive.
Be positive. Okay. So if you can remember these rules, it's just going to help speed things up for you a little bit. If you're multiplying an odd number of negative factors together, you always get a negative. You multiply an even number of negative factors together, you always get a positive. If you cannot remember these rules, then you're just going to have to what? Work from left to right, multiplying 2 numbers at a time. You eventually will get the same result anyways. I'm just saying, if you can remember the rules above, I mean, it'll get you your result quicker, okay? If not, you're gonna have to work from left to right, multiply 2 numbers at a time. You'll still get the same answer either way. So you don't have to memorize those rules. I just thought I'd throw them out there in case anybody wanted to latch onto those. All right, any further questions on this page here? Okay, so there's no other questions right there? Okay, that page. Okay. All right, how about the rules for division? I have some good news for you. The rules for division are the same as the rules for multiplication. They're the same. So when I divide a positive by a positive, or if I divide a negative by a negative, in both cases, I always get a what?
Positive.
Positive. If I mix the signs and divide, like if I take a positive divided by a negative, or if I take a negative and divide it by a positive, in both cases, I always get a negative. So the rules for division are precisely the same as they are for multiplication when it comes to signs. No difference. So let's go over a couple examples. If I have this right here, this is saying what? This is saying negative 32 divided by what? 4? Positive 4? So what's a negative divided by a positive?
Negative.
Negative.
It will be a negative, so it's going to be a negative 8.
8.
Negative 8. If I have negative 18 divided by negative 6, what do you think this is going to simplify to?
Positive 2.
Yep, a negative divided by a negative is always a positive. So this will be a positive. 6 divides in 18, how many times?
Oh, 3.
Positive 3. Yep. Notice a negative divided by a negative is a positive. All right, so this is how division works, same as multiplication. Negative 45 divided by a negative 5. Could rewrite that as a fraction like this. What does this give me? Positive or negative 9?
Positive.
Positive 9. You're correct. Positive 9. All right, positive 9. So these are the last rules of signs that we have to remember now, ladies and gentlemen. Positive divided by a positive or a negative divided by a negative is always a positive. Positive divided by a negative or a negative divided by a positive is always a negative. Now it's just a matter of getting good with these rules of signs, and that's only going to come through, practice. All right. And of course, the order of operations that we learn for whole numbers transfer right over into our sign numbers too. Nothing changes with the order of operations. I mean, we're still going to have to proceed the same way. Okay, so what am I going to do first here? Am I going to multiply or am I going to add? Order of operations.
Multiply.
Multiply.
Let's do the multiplication first. So what's a negative times a negative? A negative 5 times a negative 5.
Positive.
So it'll be a
Positive 25.
positive 25. And what's 25 plus 6?
31.
31, correct? That's the result. All right, what if we have this here? What if we want to simplify this fraction here? A -5 in the numerator times a -5 divided by -15. What do we do first in the numerator? Well, we only have one thing to do, multiply. What's a negative times a negative?
Positive.
Always a positive. So this will be positive 25 over -15. Now, can we reduce 25 over -15?
Yeah. 5 can go on both.
We reduce the numerator and denominator down by 5. 25 divided by 5 takes it down to 5.
Over
Negative
3.
15 divided by 5 takes us down to -3. So 5 over -3. That's what 25 over -15 reduces to. Just leave it like that then. Okay. So the order of operations also come right along into working with sign numbers too. Not only do they work for whole numbers, they work for sign numbers. I'll be honest with you, ladies and gentlemen, they work for all kinds of numbers. It doesn't matter. The order of operations are always in effect and always valid for any types of numbers. So what would we do first here to simplify this? Multiply or add?
Multiply.
Multiply.
Multiply here, we're gonna multiply here before we even think of addition. So a negative times a negative is always a
Positive.
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 Positive 18 plus a positive 4 multiplied by a negative. What's a positive times a negative?
Negative.
Always be a negative. Oops, always a negative. So 4 multiplied by a -2 will be a -8. Now what's 18 plus a -8? Now we have to shift gears back 2 days ago. What's a positive plus a negative? Take the what? Difference? Attach larger sign?
So it'll be 10.
Positive 10, you are correct. That's what this simplifies to, is 10. All right, so that one's done. Try to simplify 27, subtract 2 times a -4. All over -3 times 5. In the numerator, what do we do first here?
Multiply.
Should multiply here. Now, so we're gonna have 27. The minus sign, you're just gonna have to bring down then. So what's positive 2 times a -4? Positive 2 times a -4.
-8.
-8. We'll enclose this in parentheses for clarity. Downstairs, what's a -3 multiplied by a +5?
Negative 15.
Negative.
15, right?
A negative
All right.
20.
Back up in the numerator, subtracting a -8 is like adding a what?
Positive 8.
Positive 8. 27 plus 8 is what? 30, is that 35, I believe?
Yep. 35.
All right, can we reduce, I mean, 15 does not divide evenly into 35, but can we reduce this down? Always try to.
Yes.
fractions.
Divide by 5.
Yeah, top and bottom are divisible by 5. So we can take this down to 7 over negative, what, 3?
-3.
That would be your final result, okay? All right, so notice we're adhering to the order of operations as we simplify these fractional expressions here. Any questions so far here with the order of operations here? So the order of operations, work for negative numbers the same as they work for positive numbers. There's no difference. All right, help me simplify this expression here. What do I do first? Do I multiply first, deal with exponents, or subtract?
Exponents.
Exponents. Must simplify -5 squared and must simplify -3 squared. -5 squared is saying to do what? It's saying to take -5 times itself, is it not?
Yeah.
Squaring -3 means to take -3 and multiply it by itself. So what is -5 times -5?
Positive 25.
Positive 25. So we'll have 2 times positive 25.
Come in. Oops, I'm sorry.
Now what's a -3 times a -3? Right here, which was -3 squared.
9.
9, positive 9, all right. Finally, we multiply before we subtract. What's 2 times 25?
50.
Positive 2 multiplied by a positive 25 is a positive 50. What's a positive 4 times a positive 9?
36.
And finally, what's 50 subtracts 36? Either you can do it that way or you can turn it into 50 plus a negative 36. Either case, we're going to get what?
24.
24.
Wait a minute.
Oh, wait a minute. 20.
Wait a minute. Okay, minus 6 is 4.
14.
Yeah, 14.
There you go. 14.
4 minus 3 is 1.
And there we go. We got a 14. Okay. So these order of operations, again, ladies and gentlemen, don't change. It doesn't matter if we play with positive or negative numbers. The order of operations are always the same. I mean, nothing changes with the order of operations. And that goes for grouping symbols too. The order of operations are still in effect. So to simplify this expression here, 6 subtract 3 times the quantity negative 5 subtract 3 times negative 1 squared. We want to simplify this expression. Of course, we're going to have to remember the order of operations or else we're going to get this all messed up. So where does the action begin here? Order of operations.
Inside the brackets.
Okay, inside the brackets we are, and notice inside the brackets I see subtraction, I see multiplication, and I see
Start with that exponent.
Yes, we must do the exponent first inside the bracket. Put an equal sign, bring everything down to this line, next line. All right, now what is negative 1 squared? Well, negative 1 squared is negative 1 times what? Negative 1, isn't it?
Yep.
What does that net us? What is a negative 1 times a negative 1?
1.
So it's 3 times what? A positive 1 here, correct?
Mm-hmm.
There. All right, we're still inside the brackets. Do we what? Subtract or do we multiply next?
Multiply.
3 times 1 is just what? 3?
Yep.
I have negative 5 subtract just what? 3?
Mm-hmm.
Still inside the brackets. We have to subtract. We change subtraction to what? Addition and add the opposite. What's the opposite of 3?
Negative 3.
That's 3.
What's a negative 5 added to a negative 3? A negative, remember, a negative plus a negative is always a what? Negative, and we add. So this will be a negative what? 8? Finally, do we subtract or do we multiply?
We multiply. Then
Gotta
3 and
multiply
8.
Yeah, 3 times negative 8 is next up. Bring the 6 down, see the minus sign? Just drop the minus sign down. Now, what's 3 times a negative 8? 3 times a negative 8.
24 or is it?
Negative.
Yeah, positive times a negative is a what? Negative, so it'll be negative 24. Finally, we got 6 subtract a negative 24. What does that give us? That's 6 plus a what? Positive 24,
Yep.
which is,
30.
and there you go. That would be your final result from that problem, 30. Order of operations. It doesn't matter how complicated it gets, as long as you remember the order of operations and chip away at the problem one step at a time, everything's going to be great. We can't forget the order of operations though. Because as soon as we do that, like I said, that's usually when bad things start to that's when bad things start to happen. Okay. Okay, I'm going to go to the textbook now, and I want to go look at a problem in our textbook. So I'm going to go to page, let's see, 57. So in our textbook, I'm going to try to bring up page 57 here. I hope my machine's cooperating tonight. All right, page 57. Slow. All right, I think it came up. I wanted to look at problem 132. Problem 132. This is problem 132 on page 57. It says if 8 people invest $500 each in a stamp collection, and after a year, the collection is worth $3,800, how much did each person lose? Well, how much money went into the pot to begin with? We had 8 people that invested what, $500 each, correct? So instead of adding, go ahead.
I was gonna ask, would you multiply the 500 by the 8
Yeah,
people?
exactly. Instead of adding 500 to itself 8 times, Liz, why not just take 500 and multiply it by 8? That gives you the total amount of money that was invested in the stamp collection here. Okay. Okay, so, but notice it says after 1 year, the total value of this, what was put into the stamp collection only amounted to $3,800. So yeah, we had 8 people that contributed $500 a piece. So the total amount of money that went into our stamp collection is this, right? Minus, how much was the stamp collection worth at the end of 1 year though? It was only what, $3,800? So ladies and gentlemen, if we do this calculation, we're gonna basically get the amount that was what? Amount lost. Do you agree?
Yeah.
That's the amount of money that was lost. Because the amount of money that went into the stamp collection is 8 times 500, which is $4,000. $4,000 went into the stamp collection. But it says the stamp collection was only worth $3,800 at the end of the year. So how much did we lose? What's the difference between what it went in versus what the collection is worth?
200.
That would be $200. So that's the amount of money that was lost, $200. But to answer this question, they don't want to know how much money was lost. They want to know how much each person lost.
Divide by 8.
There you go. So we're going to have to take the total amount that was lost, which is $200, and we're going to have to divide it by 8 people, right? To determine how much was lost per each of these 8 people. So what's 200 divided by 8?
25.
All right, and so that gives you what, $25?
Yep.
So $25 was lost by each of the 8 people. That's how much each of the 8 people lost, $25. Did that problem make sense how we negotiated that? So each person lost $25. There were 8 people, so we lost totally 8 times 25, or $200 was lost. Okay. All right, I just wanted to look at that there. All right, time for classwork number 1. Please, in your email message for the subject of what your email pertains to, please put math 0. You can put a space here, ladies, on the space, math space, and then 082. Then after that, you can put anything you want. So we'll call this classwork 1 for September the 15th. I would like you to try a couple problems here. Okay. Problem number 1, I would like you to try to simplify this. 10 times -3, subtract 20, and all that's going to be divided by 5 times a -2. Number 2, I want you to simplify this. 7 subtract 3 times quantity, -6, subtract 4 times quantity, -2 minus 1. See if you can do that problem there. And one more. See if you can simplify number 3 here. 3 times -5 minus 3 plus 4 times 7 minus 9. And ladies and gentlemen, I'm going to add a little something extra to that. I have a square there. And all this sits over. Okay. All this is going to sit over 5 times -2 squared plus 3 times -4 squared. See if you can do something with that problem. Okay. All right, I'll give you time to work on that, see if you can simplify those there. One more time. Anybody want to give us the answer for number 5? Feel confident enough?
I got 0.
Okay, 0. Anybody else get 0?
I got 5. Are we talking about the first one?
Yes, first one.
Yeah, I got 5.
3,
All right. Anybody else get 0 or 5?
5,
5? All right, well, let's take a look here and see what we got. All right, well, let's see. In the numerator, we need to multiply before we subtract. So 10 multiplied by a -3 is a -30. Denominator, multiply 5, +5 times a -2, -10. Back in the numerator, -30 subtract 20 is the same thing as -30 plus a -20. -30 added to a -20 is a -50. What's a -50 divided by a -10 now? Negative divided by a negative is a positive. Positive what? 5?
Yep.
Okay, if you did not get 5, do we see where the mistake occurred?
Yeah, I do.
Okay. So we see where the error occurred there, huh? Now, that's the important thing. If we make a mistake, ladies and gentlemen, the important thing is to just go back and try to troubleshoot exactly where the mistake occurred. By doing that, we can turn it into a learning experience and not fall into that same trap again. All right, number 2, anybody get an answer?
got 37,
All right, 37. Anybody else get that? Number 2. So you got 37.
I got -68, but I don't know if I did that right.
All right, so -68.
I got 24.
-24. All right, so there's quite a few different answers here.
I got -11.
-11,
Negative
Okay.
50.
-54. I've heard about 4 or 5 different answers.
Oh, wait, I missed it.
No, negative 37.
Okay. Ashley, just to answer your question, this is classwork we're doing right now in class. Okay, this is what is due by midnight tonight, classwork. What's due by tomorrow night, midnight? Anybody?
Quiz.
Whiz. Textbook homework is due when again?
Exam
Nine.
date.
The day of the exam. All right.
Did somebody say they got 11?
Somebody said they got, was it 11?
I don't know.
I got -11.
-11?
Okay, because I got 24, but I messed up a step, so I got 11 now. I don't know if it's negative or positive.
You
So
got positive 11? Oh, you're not sure?
Yeah,
Positive?
I got 11, but I don't know if it's right.
All right, we better look at this problem, ladies and gentlemen, because I've heard, like I said, about 4 or 5 different answers here. All right, so here's the original problem right here. Order of operations have us in the innermost nested set of grouping symbols right in here. These parentheses are nested inside the brackets. We need to do -2 subtract 1. And -2 subtract 1 is the same thing as -2 plus a -1. And so what is -2 subtract 1? Negative what? -3?
Yes.
Okay, -3. All right. So therefore, -2 subtract 1 is -3. We're still inside the brackets. We have to do multiplication next before we do subtraction. So we must take 4 multiplied by a -3. Notice this minus sign here, you just bring it on down. Bring the minus sign on down. 4, +4 multiplied by -3 is a -12 then. So you're subtracting off 4 times -3 or -12. Gotta be careful in there. Still inside the brackets, subtracting -12 is like adding what kind of a 12?
Positive 12.
Positive 12. True. Right here. Still inside the brackets. What's a -6 added to a positive 12?
6.
Positive 6. All right. Now we have subtraction and multiplication left. What do? Subtract or multiply?
Multiply.
Multiply 3
Yep.
times.
Just bring the minus sign down, bring the subtraction sign down. And it'll be subtracting 3 times 6 or subtracting what? 18. Everybody see that there? Subtracting 3 times 6 or subtracting 18. Finally, 7 subtract 18 is the same thing as 7 plus a -18, which gives you what?
-11.
Yeah, should be -11, ladies and gentlemen. -11. Now, I heard a lot of different answers, but if you did not get -11, do you see where the mistake occurred in your work? Do you see where the mistake occurred? That's why it's very important to show your steps. You know, by showing your steps, it's easier to go back through and troubleshoot where the problem occurred. That's why it's critical to show your work. Okay. All right. So if we did not get -11, are we satisfied where the mistake occurred or not?
Yes.
So we understand where the mistake occurred. Okay.
Yeah.
That's what it's all about, is that we just, go back and investigate and learn, what did or did not happen. That's the important thing. Okay. All right. So that classwork will be due by what? You will email that to me by midnight tonight, correct? Classwork, you always email to me by midnight of the day that we do it in class. All right, ladies and gentlemen, that's the end of that section there.
We didn't go
You
over
got it,
number
number 3.
Whoa. My bad. Number 3. Did anybody get number 3?
No.
I got -2/17.
-2/17.
I got -1/4.
-1/4. Okay. Anybody else get anything different? All right, so I heard -2/17 and I heard -1/4. Anybody else want to contribute something different? All right, we better look at this one then. And of course, make sure you always copy it down correctly from the book to your paper or from the screen to your paper, because if we don't copy it down correctly, that means we're doing something else, some other problem.
I see what I did.
And obviously that's going to be an error, isn't it? That will obviously cause an error. So yeah, try to make sure we copy things down correctly as we transfer them from the book to our paper or from the screen to our paper or for them. Okay. Because that's a common mistake, not copying things down correctly. It happens all the time. All right, so here we got a big old expression here. In the numerator, we have parentheses here and here. I think we have to go inside the parentheses first here. So we have to do -5 subtract 3. And we have to do 7 subtract 9. And what is -5 subtract 3? That's -5 plus a -3, which gives us what? What is that going to give us?
-8.
-8. What's 7 minus 9? Same thing as 7 plus a -9. What would this give me in here? 7 subtract 9.
-2.
-2. -2. Downstairs, we have exponents to deal with. -2 squared, -2 times -2 should be what? 4? 4 times 5. -4 squared, -4 times -4, ladies and gentlemen, should be 16. 16 times 3. All right, so here we go. After doing all those things, we get our problem down to this now. 3 times a -8 plus 4 times a -2 squared over 5 times 4 plus 3 times 16. In the numerator, what do we do next? Do we multiply, add, or exponents?
Exponents.
Exponents. We need to simplify -2 squared. And -2 squared means to take what? -2 times -2, which gives us a what? +4, correct? So this is replaced with 4. 4 times 4. In the numerator, we have to multiply then next before we add. 3 multiplied by a -8 is -24. 4 times 4 is 16. In the denominator, we have nothing but multiplication to do before addition. 5 times 4 is 20 and 3 times 16 is 48 there. Okay. So what's 3 times a -8 in the numerator? -24. And 4 times 4 is 16. All right, and that sits over 20 plus 48. 20 plus 48 is what? 68. Now what's -24 plus 16?
-8.
-8. So we'll have -8 over 68. And can we reduce -8 over 68? Well, since both numbers are even, 2 will divide into both 8 and 68. So you can reduce the numerator and denominator down by 2 to take it down to -4 over 34. Can we further reduce -34 over 34? You can divide the top and bottom again by 2. And that takes it down further to -2 over what? 17? I think I heard -2/17 from at least one person.
Yeah, I said it.
Okay, now look, if you did not get -2/17, do we see where the error occurred, ladies and gentlemen? Do you see where the error occurred? Do you see where the mistake occurred? There's a lot of room for error in these problems. I mean, don't get me wrong. If you're not concentrating or maybe rushing through the problem, there's gonna be a lot of mistakes. So we got to be very careful as we meticulously go down through this problem one step at a time. Okay, one step at a time.
I have a question.
Go ahead.
Okay, when you did those exponents, okay, that's where I messed up. I multiplied, I messed up big time. I multiplied 9 times 9.
Well,
So
okay.
my answer was
Uh-huh.
like super off.
Yeah, you
Okay.
want to do what's inside the parentheses first. So you want to do 7 minus 9 first, which gives you what? A -2. You see that?
Right.
Then a -2 squared is -2 times -2, or what? +4
Four.
down here.
All right, I see where I messed up. Okay.
Okay. Okay. All right. Well, I'm really happy to hear that you at least, we're going back and investigating if we're making a mistake, because that's really what it's all about here, ladies. I mean, if we were perfect on all these problems, we probably should not even be in the course. We should be maybe in calculus, whatever. So we're gonna make mistakes. Most important thing is what you do with the mistake. Okay, you can either A, learn nothing from it and just brush it aside, or B, you can revisit the mistake and try to turn it into a learning experience. That's the important things, that we learn from our mistakes. That way, tomorrow, we're a better person than we were today. All right. So any other questions on this problem here, or any other ones in here? Okay. Well, let's put that section to rest then. All right, ladies and gentlemen, we have just one other section, 1.2, which is going to address fractions. I know I talked about fractions a little bit in an earlier section, did I not? I know I mentioned them. But we're
I
gonna,
think that's the day we ran out of time.
yeah, I know, I kind of rushed through some of the fraction things here. But we're gonna get into fractions a little bit more earnestly here, ladies and gentlemen. All right, the first thing we're gonna do here is we're gonna learn how to write what is called the prime factorization of a number. The prime factorization of a number. Oh, what is a prime number? Anybody want to give me the definition of a prime number?
A number that cannot go into itself.
See, a number that cannot go into itself. Well, let's see. Any number divides into itself, doesn't it? Any number divides into itself. Like 2 divides into itself 2, 3 divides into itself 3, 5 divides into itself 5, 100 divides into 100. Okay, a prime number, ladies and gentlemen, is any whole number greater than 1 that is divisible by only 1 and itself. All right, let me give you some examples of some prime numbers here. 2 is the only even prime number that exists, by the way. Why is 2 a prime number? Well, 2 is definitely, greater than 1. And the only things that numbers that divide into 2 evenly would be what? 1 and 2. Do you agree? 1 and 2 itself. Isn't that true? So 2 is only divisible by what? 1 and itself. Only 1 and 2 divide evenly into 2. There are no other numbers that divide into 2. So it's prime. 3 is a prime number because the only numbers that divide evenly into 3 are 1 and 3 itself. Is 4 a prime number? 4 is not prime. Not a prime number. Because, ladies and gentlemen, in addition to 1 and 4 dividing into 4 evenly, what's another number that divides into 4 evenly?
2.
2. 2 also divides, okay, into 4. So 4 is not a prime number because in addition to being divisible by 1 and itself, it's also divisible by 2. Is 5 prime?
Yes.
5 is a prime number because 5 is only divisible by 1 and 5. Is 6 prime?
No.
6 is not prime because other than 1 and 6, there's other divisors of 6, namely what? 2 and 3 also divide into 6. So 6 is not a prime number. 7's prime. 8 is not prime because 2 and 4 divide into 8. 9 is not prime because 3 divides into 9 in addition to 1 and 9. 10 is not prime because 2 and 5 divide into 10. 11's prime. Only 1 and 11 divide into 11 evenly. 12's not prime. 12 has many divisors. 1, 2, 3, 4, 6, and 12 all divide into 12. 13 is a prime number because only 1 and 13 divide into 13 evenly. 14 is not prime because 2 and 7 divide into 14. 15 is not prime because 3 and 5 divide into 15. 16 is not prime because 2 and 4 and 8 all divide into 16. 17 is prime. 18 is not prime. 19 is prime. 20 is not prime. 21 is not prime. 3 and 7 divide into 21. 22 is not prime. 23 is prime. 24 is not prime. 25 is not prime. 26 is 26 prime?
No.
No, because 2 and 13 divide into 26. 27 is not prime. 28 is not prime. 29 is prime. 30 is not prime. 31 is prime. Okay. So ladies and gentlemen, I have a question for you. How many prime numbers do you think exist? I just listed, the first several here, but do you think there's any more?
Yes.
There are. And in fact, there's an infinite number of prime numbers. This list goes on forever. There's an infinite number of prime numbers. I'm not going to sit here and list them all because we'll never get out of this course. All right. All right. So ladies and gentlemen, here's what we're going to learn how to do. Suppose I have a number that's not prime, like the number 20. Suppose I want to write the prime factorization of 20. Write the prime factorization of this number 20. How do we do it? Well, what we can do is we can build an upside down tree. 20 is like the roots of the tree. We have 2 branches coming out of 20. Can you give me 2 factors of 20, 2 divisors of 20? What times what gives me 20? Can you give me an example of some numbers?
5 and 4.
All right, 5 and 4 or 4 times 5. Okay. Now, is 4 a prime number or can it be further factored down?
2 and 2.
4 is not prime. It can further factor down. So there's 2 more branches that come out of 4 because it further factors down into 2 times 2. Are these 2's prime?
Yes.
2 is the
Yeah.
only even prime number that exists, by the way. All right, so these 2's are prime. I will circle them. They become the leaves of our tree. 6, is it prime? I'm sorry, 5. Is 5 prime?
Yes.
In my
Yeah.
list. Circle 5, and we're done. So ladies and gentlemen, 20's prime factorization is 2 times 2 times 5. 2 times 2 times 5 is 20. We call this the prime factorization of 20. Can I see that there? Because we've taken 20 and rewritten it as the product of nothing but primes. If you want to use exponents, you can tidy this up and call it 2 to the second power times 5. That's the prime factorization of 20. Any questions with what I just did there? I took the number 20 and I wrote its prime factorization. I wrote it in prime factored form. Let's try that out with another number. Okay, do we all have this down here, accounted for? All right, let's try it out with another number. How about the number? Darn thing's blurry here. I don't know why. How about the number 128? Suppose we want to write the prime factorization. of 128. Can anybody give me a number that divides into 128 evenly? It is an even number, isn't it? It ends in an even digit. So what divides into 128 automatically?
2.
Two
The
will.
two?
Two will. And off to the side of your paper, you can, do your long division here. So 2 goes in at 12 6 times. Bring down the 8. 2 divides in 8 4 times. So 2 divides in 128 64 times. So we can start building our upside down prime factorization tree. 2 times 64. 2 is a prime number, circle it. Can 64 be further factored down?
Yes.
8.
Maybe 8 times 8. Or you know what? I could have said 2 times 32. You don't have to say 8 times 8. You can say 2 times 32 also. Right. Are these 8s prime or can they further factor down?
They can factor down.
They further factor down. And each of these 8s further factor down into what? 2 times 4. 2 is prime, circle it. This 8 further factors down into what? 2 times 4. Circle the 2, it's prime. These 4s can further what? Factor down, can't they? What do they factor down into?
2.
2 times 2, both of which are prime, circle them. This 4 factors down into 2 times 2. We're done because we have nothing but leaves left over here. So what is the prime factorization of 128? 2 times 2 times 2 times 2 times 2 times 2 times 2. How many 2s is that?
7.
So this is one way to represent the prime factorization of 128, or if you want to be a little bit more compact, you can use exponents. This is really 2 to the what power?
7
2 to
power.
the 7th power. Ladies and gentlemen, we have written the prime factorization of 128. It's 2 to the 7th power. Anybody see how this is working here? You can always write the prime factorization of any number that's not a prime number. Long as it's a whole number. It's got to be a whole number. All right. So 48. Is 48 a prime number or can it be factored down?
It can be factored down.
Give me some factors of 48.
12 and 4.
You could go
Is that-
4
wait.
times 12, or you can go 2 times 24, or you can go 3 times 16, or you can do 6 times 8. Do you agree? You got a lot of choices here. Just grab a couple. Which ones? Which ones you want to go with? 2 times what? 2 times, what was that again?
6 and 8.
6 and 8. 6 times 8. You can start there. 6 is not prime. It further factors down into what?
2 and 3.
Finally, 2 and 3 are prime numbers. Circle them. 8 can further factor down into what? This 8.
2 and 4.
2 times 4. 2 is prime. Circle it. 4 is not prime. It can further factor down into,
2 and 2.
and we're finally done. And so what is the prime factorization of 48? 2 times 2 times 2 times 2 times 2 times 3. It doesn't matter what order you list these factors. You could have 2 times 3 times 2 times 2 times 2. I like to put them in order from left to right, smallest to largest. So 2 times 2 times 2 times 2 times 3. And there you go. That'd be the prime factorization of 48. Or if you want to use exponents, you can say this is 2 to the 4th power times 3. Prime factorization of 48. Let me ask you this question. Has anybody done this before in any other class before this one?
High school.
High school.
Okay, so I mean, you have seen this before, correct? I mean, so it's not totally alien to us. That's a good thing. That's only more power to you. All right, so ladies and gentlemen, reducing fractions. Why is 5/7 already reduced? Why is that already reduced?
Break those numbers down.
What's
I mean,
that?
they prime number. I mean, those are prime numbers, right? You can't break them down. They
Yeah.
already reduced. They're already reduced.
Yeah, the reason why this is reduced is not because these are necessarily prime numbers. They're reduced. This is a reduced fraction because the only number that divides evenly into the numerator and the denominator is 1. Do you agree? 1 is the only number that divides into both the top and bottom. That's why we call it reduced. All right, so don't think that they have to be prime numbers for the fraction to be reduced. For instance, 5/12. 12's not a prime number, and yet I claim this fraction is reduced. Why is it reduced?
Because one can
Because-
only go into each of them.
That's right, because the only common divisor that both the top and the bottom of this fraction has is 1. No other number than 1 divides into both 5 and 12 evenly. That's why we say 5/12 is reduced. Okay, it's reduced. All right, now let's try another one here. Let's try to reduce, let's say 12 over, let's say 36. 12 over 36. Ladies and gentlemen, there is another way we can reduce this fraction without trying to think of a number that divides into both the numerator and denominator. Here's slightly a longer way of reducing this, but it always works. It'll always pay the bills. If you take the numerator off to the side of your paper, let's write it in prime factored form. So help me write the prime factorization of 12.
6 and 2.
Okay, 6 times 2. 2's prime, circle it. 6 further factors down into what?
3 and 2.
3 and 2, both of which are finally prime. So the prime factorization of 12 we say is what? 2 times 2 times 3?
Yes.
Yep.
I'm going to come up here and replace my numerator with its prime factored form. 2 times 2 times 3. Good. Let's do the same thing with the denominator. Let's write it in prime factored form. So help me get started here. Give me some factors of 36.
6 and 6.
6 times 6. Both of these 6's, however, further factor down into what?
3 and 2.
3 times 2 here. Both of these are prime, circle them. 3 times 2 here. Both of these are prime, circle them. So do you agree the prime factorization of 36 is 2 times 2 times 3 times 3?
Yep.
2 times 2 times 3 times 3. Now look at, now that I have both the numerator and the denominator written in prime factored form, it's very easy to see what reduces out here. Do you agree this 2 will divide into itself once and divide in this 2 down here once? We say these 2's reduce down to 1. These 2's reduce down to 1. Do you agree? This 3 divides into itself once, divides into one of these 3's down here once. And what are we left with in the numerator? A bunch of 1s. And when you multiply a bunch of 1s together, you're left with 1, correct?
Yep.
What do I left down have in my denominator? What do I have left? 1s and times of what? 3? We got 3. Ladies and gentlemen, I have reduced 1236 down to 1/3.
Wow.
This is called the prime factorization method way of reducing fractions. You see that there? Isn't that neat? Now, some of you might not want to, go through all this work. And I understand. I mean, this is a little bit drawn out, but I'll tell you what, the nice thing about this is it always works though. It will always get you down to your reduced fraction. So keep in mind, if you're struggling to reduce a fraction, try breaking up the numerator, denominator, and the prime factors, and then reduce them down. Okay, like this, like I did here. The more direct way of reducing this is to ask yourself, can I think of a number that divides into both 12 and 36? Can you give me any number that divides into them?
6.
So remember, I introduced ourselves to fractions by talking about equivalent fractions. Ladies and gentlemen, as long as you divide the numerator and denominator by the same thing, you still crank out an equivalent fraction. So if you divide the numerator and denominator of this fraction by 6, you can take it down to 6. So 2/6 is equivalent to 1236. They're called equivalent fractions. Can I further reduce 2/6 down though?
1/3.
Yes.
Yeah, 2 divides in the numerator and denominator again, and we can take this all the way down to 1/3. And so we see 1/3 is equivalent to 2/6, which is equivalent to 1236. These are all equivalent fractions, and you cannot reduce 1/3 down anymore. So how are you going to reduce fractions, ladies and gentlemen? Do you like this prime factorization method? Or
Yeah.
you like the brute force? They sometimes call this the brute force method. You like the brute force method, or you like the prime factorization technique?
Either or.
Either way, I mean, both methods work. They're both viable options. Okay. I don't really care what method you choose, in all honesty, on a quiz or exam. I just hope you can show me some sort of work one way or another and then get it reduced. This is showing work by the brute force method. This is showing me that you're reducing the top and bottom down by 6 when you show this and write this. Please do write that. This is showing me you're reducing this further down by 2, down to 1/3. Obviously, this is showing me work with this technique. Do you agree? By doing the prime.
So every problem, like we had a quiz or something, like, do you want us to always reduce our answers all the way down? Or
Yeah, in general, when you do have fractions, I would like your fractions to be reduced, okay? That's kind of like a common courtesy in mathematics, is to always try to reduce your fractions with problems, if possible, all right? Okay, so always try to reduce fractions. That will be kind of like an unwritten rule from now on. All right, okay. So now, how do we multiply fractions together? How do we in general multiply fractions together? Well, the good news is we don't need a common denominator. Some people think you need a common denominator when you multiply fractions together. You do not. To multiply fractions together, ladies and gentlemen, all you do is just multiply your numerators together and place that product over the product of your denominators. So when you multiply fractions together, you just multiply your numerators together, multiply your denominators together. And then, of course, you always try to do what with this fraction in the end, if possible. Always try to make sure it is.
Reduced.
Yeah, always try to reduce it if you can, okay? If you can. Sometimes you can't, but sometimes you can. All right, so let's try a problem out here. If I have like 3/4 multiplied by a negative 8/10, okay? So how would I multiply these together? Well, we can never forget our rules of signs, as there will be some positives and negatives mixed in from time to time. So first of all, what is a positive times a negative here? Positive times a negative.
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 It will be a negative. Our product's going to be a negative. And now, how do we multiply these fractions together? So it is going to be a negative. Okay, so we go 3 times 8 over 4 times 10. So this is going to be a negative 24 over what, 40. Can we reduce this?
Yes.
Yes, please do. Now, I don't care how you reduce this. I mean, if you want to, just use the brute force method, just try to think of a number that divides into both top and bottom and take it down that way you can. Some of you might, decide to use the prime factorization method and rewrite 24 as 2 times 2 times 2 times 3, and tear 40 down all the way down into 2 times 2 times 2 times 5. By writing the numerator and denominator in prime factored form, it's very easy to see how this reduces now. These 2's reduce out to 1's, these 2's reduce out to 1's, these 2's reduce out to 1's, and we're left with what? Negative what over what? Negative 3/5? Isn't that true?
Yep.
Or if you don't like the prime factorization method, no problem. Give me a number that divides into both 24 and 40. Can you think of a number?
4.
4. So what we could do is we could reduce negative 24/40 down by 4 by dividing the top and bottom by 4. And that takes it down to the equivalent fraction of negative 6 over 10. Negative 6 over 10, correct? But can I further reduce negative 6 over 10?
Yes.
By what?
Two.
By 2. And that takes us down to negative 3 over 5. Do you agree I get the same answer either way?
Yes.
Same answer. I'm going to leave it up to you as to how you reduce fractions, ladies and gentlemen. It's entirely up to you. The bottom line is just try to show me some sort of work and I'm happy, okay? But there's different ways of reducing fractions. So I'm going to leave it up to you. But the product of these fractions reduces down to negative 3/5. All right. And of course, you got to be, conscious of your sign rules too. Don't lose your sign rules, because there's going to be signs mixed in with these operations also, positives and negatives. So just a lot to try to remember, I know, but with daily rehearsal of these rules, I think things are gonna work out, you know, they should work out okay. Now, what if we have like negative 15 over 40, and we want to multiply this by like negative 8 over 18? So I'm going to multiply these two fractions together. And first of all, I might want to take care of the signs first. I have a negative times a negative here, and that should give me a what? What's a negative times a negative?
Positive.
Negative.
Positive.
Positive.
Negative times a negative is always a positive. A negative plus a negative is always a negative, but a negative times a negative is a positive. So when I multiply these together, when I get done, it's going to be a positive, guaranteed. Now we want to take 15 and multiply it by what? 8. But ladies and gentlemen, I'm going to hold off on multiplying the 15 times the 8 just for a second, because I'm going to show you something. Likewise, I could do 40 times 18, but do you agree that's going to give me a very big number, 40 times 18?
Yes.
Well, I'm gonna hold off. I'm gonna hold off on multiplying 40 times 18 together. Okay. Now, why did I hold off and not actually multiplying the 15 and the 8 together and the 40 and the 18? Because here, what's that?
Reduce them down.
Yeah, because here's why. Look at, instead of multiplying these together right away and getting huge numbers of which we would have to try to reduce then, why not try to nip this in the bud here a little bit, ladies and gentlemen? For instance, you can see we got 15 over 40 and 8 over 18. Can maybe I reduce 15 over 40? Can you think of a number that divides into 15 and 40?
5.
5 will. Do you agree, ladies and gentlemen, I can reduce the 15 and over the 40 down by 5? 5 divides into 15 what? 3 times. 5 divides into 40 what? 8 times. Can I not take that down to 3? And take the 40 down to what? 8? You think it's legal to do that?
Yes.
Perfectly legal to do that, ladies and gentlemen. Now, can you see anything else that might reduce between the top and bottom here? Any of these other factors?
8, 18.
Look at these 8s here, ladies and gentlemen. 8 divides into itself once and divides into this 8 down here once. The 8s reduce out to 1. Heck, we got this thing down to 3 times 1 over 1 times 18. We got it down to 3 18s. Can I further reduce 3 18s? Can I further
Yeah.
reduce this? Yeah, I mean, this
Yeah.
further reduces down by what number? By 3?
Over
All right.
6.
So I can take this down to what? 3 divided by itself is 1. 18 divided by 3 is what? 6. There's your final answer, 1/6.
Can
So
we
my-
backtrack? Can we backtrack for a second? I'm super confused.
Okay, where are you confused?
So on when we reduced the 8s down, is that because they were similar? Right there, yeah.
Well, they're not just similar, they're identical. Do you agree?
Right.
And 8 divided by itself is 1, correct?
So it doesn't matter, like, it just has to be on the top and bottom, but it doesn't
That's
matter
right.
if they line up or not.
Yeah,
Okay.
yeah, it doesn't matter if this 8's exactly underneath this 8. The bottom line is because this 8's in the numerator and this 8's in the denominator, they still what? Reduce down to 1, okay?
Okay.
Look, if you wanted to rearrange these, look, you could do this. If you wanted to rearrange them, you could do this also. Sure. I mean, you can rearrange this problem like this. Still the same problem.
Right.
Now you can more clearly see that these 8's what? Reduce, correct?
Yes.
And we're left with 3 over 18, which further reduces down to what? 1/6 ultimately, does it not?
Yes.
Mhm.
Okay, so ladies and gentlemen, the way to deal with this problem here is there's many ways to deal with this problem. You could multiply the 15 times the 8, you're going to get a very big number. And then 40 times 18 is going to be even larger down here. Do you agree trying to reduce big numbers over big numbers is no fun? So there's times when you can do some what? Reducing, correct? Some reducing before you actually multiply the numbers together. There's times when you can do that. All right, the bottom line is we want to get it down to 1/6 here, okay? Let me ask you this. Is there anybody in this class who has learned cross canceling before?
I have.
Yeah.
You
I
have?
have, yes.
Okay, so some people have even learned cross canceling. So another way to negotiate this problem negative times a negative we know is going to be a positive. Another way to negotiate this problem is ask yourself, can you think of a number that divides into both 15 and 18? This is called cross reducing or cross canceling. Can you think of a number that divides into 15 and 18?
3.
15 divided by 3 reduces this down to 5. 18 divided by 3 down here reduces this down to 6. Can we cross cancel between the 8 and the 40? Can you think of a number that divides into both 8 and 40?
5.
Four.
5 does not divide into 8. Can't use 5.
4.
4.
4 divides into 8 2 times. 4 divides into 40 10 times. So what do we have left here? I got 5 times 2 over 10 times 6 after having done that cross canceling. Ladies and gentlemen, can I further reduce anything between the top and bottom here? 5 with a 10 or 2 with a 10 or 5 with a 6 or 2 with a 6? Any other reducing here?
All of it. 5 and the 10 and 2 and the 6.
5 divides into itself once, 5 divides into 10 twice, 2 divides into itself once, 2 divides into 6 3 times. We're left with 1 times 1, which is 1 over 2 times 3, which is what? Same answer. Do you agree?
Yep.
Just a different way of dealing with it. All right. And you know, for those of you who like the prime factorization method, that method also works, ladies and gentlemen. If you want to tear all your numerators and denominators down in their prime factored form. 15 is 3 times 5 in prime factored form. 40 is going to be 2 times 2 times 2 times 3. Wait a minute. No, that'd be times 5. My bad. Times of 5. And 8 is going to be what? 2 times 2 times 2. 18 is going to be what? 2 times 3 times 3. So if you want to tear all your numerators and denominators down in the complete prime factored form, then it's very easy to see what cancels out. Negative times a negative, still positive. Look at this. We got a whole bunch of canceling we can do here. This 3 will divide into itself once and take out one of these 3's down here, dividing into it once. These 5's reduce. This 5 over 5 reduces down to 1. This 2 reduces into itself, takes out one of these 2's here once. This 2 divides into itself once, takes out one of these 2's here once. This 2 divides into itself once, takes out this 2, dividing into it once. What are we left with? Product of a bunch of 1's, which is 1 over the product of 1's and what? 2 times 3. What's 2 times 3? 2 times 3.
6.
1/6. Same answer. I've shown you 3 different ways of negotiating this problem, ladies and gentlemen. 3 different ways, yet the same answer. So look, the bottom line is when you multiply these fractions together, your final answer does reduce down to 1/6, regardless of the way you choose to do it. Okay. You got to admit, the prime factorization method is drawn out, takes more time, but once you get everything prime factored form, it's very, very easy to see what reduces out. Trivially easy to see what goes out. Brute force method, a little more direct, but not as obvious. Okay. This method, cross canceling, always works. You can always cross cancel. It's legal to do that. Not cross multiply, cross cancel. Okay. All right. So multiplying fractions together. There's many ways to do it, many ways to show it, many ways to do it. I hope you adopt a method that works for you, ladies and gentlemen. All right, how do we divide fractions in general? So if I got A over B divided by C over D, in general, how do we divide fractions? Do you remember?
I rule for multiplication, right?
Change division to multiplication, and you got to flip the second fraction upside down. You know what I'm saying? And now we're back to multiplying. Whether you want to multiply across first, then reduce, or if you want to do some cross canceling, that's possible. Feel free to do that. Or if you just want to not actually multiply your numbers together, just put it like this and then try to reduce between top and bottoms anyway. It's up to you. Okay. Let's see if we can try a problem here. If I got 8 divided by negative 4/5, how would I do 8 divided by negative 4/5? 8 sits over what number? Understood.
1.
You can always put any number over 1, still the same number. How do we divide? Leave the first number alone, change division to what? Multiplication, flip the second fraction upside down. Ladies and gentlemen, when you flip a fraction upside down, you do not change its sign. You do not change its sign. So if this is a negative fraction, the reciprocal will still be negative. It's just going to be -5/4. Now, what's a positive times a negative? Positive times a negative is always
Negative.
will be a negative. Negative what? How do you want to deal with this multiplication now? You got 8 over 1 times 5 over 4.
Reduce 4 and 8 by,
You can cross cancel if you want to do cross canceling first. 4 divides into itself once, 4 divides into 8 twice. Then we're left with 2 times 5 left over in the numerator, and downstairs we have 1 times 1, -10 over 1, or what? -10. Okay. Or if you don't like that method of cross canceling, you don't have to use that method. You can multiply your numerators together, 8 times 5, and put that over 1 times 4. Now can you reduce between any top number in the top or bottom? 4 divides into itself once, 4 divides into 8 twice up here. You're left with -2 times 5 over 1, -10. Or suppose you don't like that method. 8 over 1 times -5 over 4. It's going to be a negative. 8 times 5. Suppose you actually multiply your numerators. 8 times 5 is 40 over 1 times 4, which is 4. But ladies and gentlemen, this what is this reduced down to?
10.
Reduce top and bottom down to 4 by
10.
4. Doesn't that take it down to negative what? 10
Mhm.
over 1? -10?
Yep.
So again, however you want to, deal with the actual multiplication of fractions, I'll leave that up to you. The bottom line is that's going to be -10 for that result there.
So when you have that number outside the parentheses like that, the 8,
Yeah.
you always put that number over 1.
Yeah, whenever you got a whole number, okay, can't you put any whole number over 1? It's still the same thing.
Right.
As long as you put it over 1, it's still the same number, correct? You can always do that, right? You can put anything over 1 and still have the same number. Isn't -5 over 1 still -5? You think that's true? -5 over 1 is still -5?
Mhm.
Still the same thing, right? Okay, adding fractions together. When we have a common denominator, ladies and gentlemen, life is good. Let's see, life is pretty good. Why is life good when we have a common denominator?
You can just
add
leave
it.
it.
Because we don't need to get a common denominator. We already got one. And when you have a common denominator, adding or subtracting is easy. You just add your numerators together or subtract your numerators and place that result over your common denominator. So 3 7s plus 2 7s gives us 5 7s. Can we reduce 5 7s?
No.
Okay. All right. So life is pretty simple when you have a common denominator. If you got 4 9ths, subtract 2 9ths, what's this going to give us? 4 subtract 2 over 9, which is going to give us what?
2 over 9.
2 9ths, which is what? Reduced,
Mhm.
correct? But later on, what happens when you don't have a same denominator? Like if you have 1/2 added to like 3/4,
You got to find a common
you
denominator.
need a least common denominator. And what is the least common denominator of 2 and 4?
4.
4.
Okay, it will be 4. Now, the next thing is you got to build these fractions up into equivalent fractions where the denominators both have to become what? 4. So what do you multiply 2 by to build it up to 4?
2.
So if you multiply the denominator by 2, you got to multiply the numerator by the same number to have an equivalent fraction. So 1 times 2 is 2. 2 times 2 is 4. So 2/4 is equivalent to 1/2. This fraction already has a common denominator of 4, so you just leave the numerator alone. So what's 2/4 plus 3/4?
5 4.
5 fourths.
All right, that'll give you 5/4, which is reduced. It's an improper fraction because the top is bigger than the bottom, but it is a reduced fraction by definition. Just leave it like that.
So if we put 1 1/4, is it wrong?
No, it's not wrong, but you don't have to go to a mixed number unless I specify, okay?
Okay.
You can just leave it as 5/4. Ladies and gentlemen, usually it's easy to look at the denominators and determine what the least common denominator is, but we're not always going to have that luxury. What if you have 5/12 added to 7/18? Now it's not that easy to determine what the least common denominator is. There is a method, ladies and gentlemen, that enables you to find the least common denominator of numbers that are very big or very hard to determine it for. What you want to do is take both these numbers, 12 and 18, and break them down into their prime factorization. 2 times 6 is 12, 2 is prime, 6 further factors down into 2 times 3, both of which are prime. 12 is 2 times 2 times 3. Do you buy that? That's 12's prime factorization.
Yeah.
12 is 2 times 2 times 3. What is 18's prime factorization? We can do 18 over here.
3 or 9, 2.
All right, 3 times 6. 3 is prime. 6 further factors down into 2 times 3. So what is 18's prime factorization? 2 times 3 times 3.
Mhm.
Ladies and gentlemen, to put together the least common denominator now is pretty easy once you have your denominators completely torn apart into their prime factors. But you have to remember something. In order to put together the least common multiple or least common denominator of 12 and 18, you need the greatest occurrence of factors between the different factorizations. Now, what's all that saying? Ladies and gentlemen, how many 2's do you see in this prime factorization? How many 2's do you see?
2,
You see 2 of them, correct? How many 2's do you see in this prime factorization?
1,
What's the greater number of occurrences of 2's between these separate factorizations? 2 of them or just 1 of them?
12,
What's the greater occurrence of 2's? 2 of them or 1 of them?
2,
2. You must have therefore 2 factors of 2 in your least common denominator. Look at the 3's now. The first prime factorization has 1 3, but the second one has 2 3's. How many 3's do I need in my least common denominator? 1 of them or 2 of them? If I want the greatest number of them,
2,
you need 2 of them. What's 2 times 2?
4,
4,
4 times 3.
12,
12 times 3.
36.
Ladies and gentlemen, 36 is the magic number. 36 is the least common denominator of 12 and 18. This is called the prime factorization method for determining the least common denominator of 2 or more numbers.
Isn't another way, I thought I learned like if you have the same, so that 2 and 2 would cross out, which would, it's the same thing, but that's the same thing, right? That I'm
Yeah.
talking about?
As long as you're going to get 36. Do you get 36?
Yes.
Don't worry about it. Then. It's the same thing. It works. All right, ladies and gentlemen, both these fractions have to be built up in equivalent fractions where your denominators have to both be 36. What do I multiply 12 by to build it up to 36? How many times 12 divide into 36?
4.
Look at 12 here. 12 was 2 times 2 times 3.
Oh, 12.
Our least common denominator has 2 times 2 times 3 times 3.
Wasn't it 3?
Yeah, do you agree the 12 already has the 2 2's? It has 1 3, but it's missing 1 3. Do you agree? That's why you got to multiply top and bottom of the first fraction by 3 to give us 15 over 36 is equivalent to 5/12. Ladies and gentlemen, 18 has to be multiplied by what to build it up to 36? 18 has the 2 and the 2 3's. It has a 2 and the 2 3's. It's missing a 2, meaning top and bottom of the second fraction gets multiplied by 2 to build it up to what equivalent fraction?
14 over 36.
14 over 36. Now that we have a common denominator, we can just add our numerators together and place that over the 36. Looks like we got 29 over 36, which cannot be further reduced. 29 is a prime number, by the way, and that would be your answer. So 5/12 plus 7/18 is 29/36. Sometimes when you cannot visually determine what the least common denominator of 2 denominators, 2 or more denominators is, feel free to tear them apart into their prime factorization. Then it's easy to see how many factors and what you need for your least common denominator. Okay. All right, ladies and gentlemen, there's no time left. I went over. So we can't do classwork 2. There's no time for that. All right, so all you owe me by midnight tonight is what?
Classwork.
Classwork 1.
Classwork 1. What do you owe me by tomorrow night, midnight?
Wait,
Quiz.
Quiz
Quiz.
on chapter 1. I will be sending that to you, emailing that right when I get off here in a moment, okay?
So just the classwork we did today, because we already turned the other ones in,
That's
right?
right. If you already
Okay.
turned the other ones in on Monday, you're good. You just gotta turn in what we did today, correct? By midnight tonight, right?
Okay.
All right, any other questions?
When do you
No.
grade stuff, the classwork we do?
What's that?
When do you like grade this stuff that we turn in, the classwork?
Well, I'm gonna get to that. I haven't set up the grade book yet, all right? I'm a little behind, but I'm gonna get there, okay?
All right, thank you.
Okay. All right, I will try to get this recording posted also, all right? So you can watch this recording.
Thank you.
yes,
All right, have a good night.
Thank you.
See you. Take care.